So let's do another one. We could let's do another one. So we'll say whoops. Let's do f of x is equal to x plus 2 times 2x minus 4. Same thing, what we're going to do is we're going to over here real quick, just put x plus 2 equals 0. So what's x?
-2.
X equals -2. We're going to subtract 2 from both sides. Also, we're going to say 2x. So what I'm doing is I'm taking this and setting it equal to 0, and then I'm going to take this and set it equal to 0. Equals to 0. I'm going to add 4 to both sides. That will give me 2x equals a positive 4. Then I divide both sides by 2, and I get x equals 2. So what does that tell you?
The points are on every 2 and 2.
Yeah, do you notice that when we set these equal to 0, that gives us the x-intercepts, right? So I'm guessing that it's going to cross here and that it's going to cross here. Maybe. I don't know yet. Maybe. How can I verify that? We're going to plug that in and graph it. So let's do that. Go to Desmos. We're going to, let's turn this off. Just click on that and we'll adjust that later, and turn this off and we'll adjust that later. Let's delete all of these values, except let's put in 2. Wait a second. Oh, wrong equation. We got to come up here and change the equation first, right? So the equation was x plus 2, x plus 2, close parentheses, and then 2x minus 4. So 2x minus 4. I'll leave that up there for a second so that you guys could type that in. And then we set both of these are called factors. And so we set both the factors equal to 0, right? And we see that it crosses the x-axis. That's no accident. And where do you think the vertex is? 0. So let's catch up. So I'm going to say that when x equals 2, y equals 0, and that's this point here, 2, 0. When x equals -2, y equals 0. And then down here, remember that we're going to use our function notation. F of 2 is equal to 0. F of -2 is equal to 0. Okay. And it doesn't make sense. I know that you guys always want to look at this and go, why do I need to write all this down? This doesn't make sense to me. Well, that's a very valid statement. But these things are all connected, right? And so this is what I'm teaching you. Sometimes it's easier just to kind of memorize the steps in the process. And then once you memorize the steps in the process, say, oh, these are zeros because of the prime factorization. And when you set it equal to 0, that means you're going to result in a factor or product of 0. So y will equal 0 when these numbers, blah, 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 blah. Sometimes it's easier just to kind of plug through some things first. Okay. And there are 4 ways, 5 ways, 6 ways to represent the data. You could do it in a graph. You could do it in an equation. You could do it in 3 or 4 different equations. Unfortunately for you guys, I have to show you all those ways. And sometimes it's easier just to do it all at once. Okay. So now let's verify if 0 is the vertex. So I'm going to plug in 0 here. But you know what I want to do too, you guys? Label these. So what we're doing is these two things are called factors. So just write down factors. Now, if you don't recall, the factors of 6 are 2 and 3. In other words, 2 times 3 equals 6. The factors of 8, or some factors of 8, are 2 and 4 because 2 times 4 is 8. These are factors because we're going to multiply these and get a quadratic equation. Okay? So we're going to plug in 0. Let's let the calculator do the work for us. 0. Well, it looks like it equals negative 8. So we're going to plug that in. When x equals 0, y equals negative 8, f of 0 is equal to negative 8, and then we're going to plot that point way down here, and I get 0, comma, negative 8. And so the reason I'm having you write all this stuff down is I want you to see that this is the same as this, which is also on here. By the way, it's no accident. What's 2 times negative 4? No, 2 times negative 4 is negative 8. So all these patterns and connections, it's not an accident that all these things are happening on every one of these problems. So anyways, I think we might have to do the decimal thing again because of the way this thing grows. So we'll try plugging in 3 for x and see what happens, but it might be way off the...
It's 10.
Is it 10? Okay,
yeah.
Good. I'm glad that you guys are working ahead a little bit. Okay, so it's 10. So we can work with that. Also, probably negative 3 is also 10, right? All right, and then we turn this off, but we could turn it back on because it's the same line of symmetry, right? Okay, so 3 and negative 3 both equal 10. So we're going to come back here and we're going to say 3 when x equals 3, y equals 10. When x equals negative 3, y equals 10. In other words, f of positive 3 equals 10. Let's plot that, 3, comma 10. And then f of negative 3 equals 10. So, my word's in the way. I have childlike handwriting. All right, cool. Let's sketch our graph as best we can. Remember, it's got to kind of look like a U. I find it easier to go from the x-intercepts through the vertex. And then it is kind of like a straight line from these to these, but not really. Ooh. Okay. Put little arrows here so you know that goes on forever. All right, let's foil this thing real quick just to make sure, and then we'll graph the foil, and then we're done. So I'm going to do a 2x2 here. So we've got x plus 2 times 2x minus 4. So remember, this is 1x. So what's 1x times 2x?
2x to the second.
2x squared, because x times x is x squared. Now what's 2 times 2x? 4x, but positive 4x. I like to write that plus sign in there because then I remember to add it or subtract it, right? Now what's 1x times negative 4? Negative 4x. And what's positive 2 times negative 4? Negative 8. Okay? All right, cool. So what we're going to do then is we're going to write this out. 2x squared plus 4x minus 4x. Man, I've been doing this a lot. That's so funny to me. All right. So when we combine like terms, what happens? Those cancel out, right? So then I'm left with just 2x squared minus 8. I'll give you a second to write that down. And probably, just for good measure so you understand, that means that this is equal to x plus 2 times 2x minus 4. Those are the same equations. It's just one is written in factored form, and the other one is just written in a standard form. Okay? But both of those have the same mathematical relationship. To verify that, I'm going to plug this in Desmos. So here's my graph, and then down here, if I put, what was it again? 2x squared minus 8. Okay, so that's they match up, right? And we've labeled all